So next topic is Dalton's atomic theory, or we also call it Dalton's model of an atom. Main points of this theory are, I'll tell you various points of this theory. These are very simple points, but interesting thing is most of these points have been proved wrong. But still we study because a couple of points are still valid, they are correct. Number one, first point, all matter is made up of small indivisible particles called atoms, which do not have any internal structure. Within brackets, write down proved wrong by Rutherford's experiment. If you remember, you might have studied about Rutherford's bombardment experiment, gold foil experiment in probably 9th standard. And that experiment proves that atom consists of a nucleus and extranuclear region. Means what? Atom has an internal structure, whereas Dalton said atom does not have any internal structure. So first point was proved wrong. Number two, all atoms of an element are identical, including masses. So that's what Dalton said. There's no difference in different atoms of the same element, including masses. There's no difference. Within brackets, write down proved wrong with the discovery of, can you tell me discovery of what?
Isotopes.
Yes, with the discovery of isotopes, because isotopes are atoms of the same element which have different masses. So that was proved wrong. Third point, atoms of different elements are different from one another. It means if you consider atoms of any two different elements, there is no type of similarity between them. Within brackets, write down proved wrong with the discovery of, yes, anyone? Isobars. Discovery of isobars. What are isobars? Isobars are atoms of different elements which have same masses. So their identity is masses are same. Fourth point, atoms can neither be created nor destroyed during a chemical reaction. So in a chemical reaction, only the reorganization of atoms takes place. Reorganization means atoms go from one molecule to another. That's what is a chemical reaction. Otherwise, atoms are neither destroyed nor they are created during a chemical reaction. Certainly, this point is valid. This point is correct. He said about this about chemical reaction. But if we consider nuclear reactions are different from chemical reactions. If we consider nuclear reactions, then mass is destroyed. Atoms can be destroyed as well as created. And when there is destruction of mass, lot of energy is released. Like in nuclear bombs, there's destruction of mass, and destruction of mass releases lot of energy. So write down within brackets, true for a chemical reaction, but during nuclear reactions, atoms can be destroyed and converted into energy according to Einstein's equation, E is equal to mc square. E is energy produced, m is mass destroyed, and c is velocity of light. So what he said, his point is valid. His point is correct, because what he said was about chemical reactions. And as far as chemical reactions are concerned, his point is still valid. Next point. An atom is the smallest particle of matter which takes part in the reaction. Tell me what you have to say about it. Is still valid or it is wrong?
Wow.
See, if maybe, why did I ask you? Because you probably have the feeling that electron takes part in the reaction. See, electron alone cannot react. It's a part of the atom which helps in bonding of atoms together. Electron does not take part in the reaction. Electron takes part in bond formation. So within brackets, write down still correct. This point is still correct, but we can't say about future. Somebody may prove it wrong in days to come. Next and the last point, atoms of different elements combine together in a fixed ratio to form compound atoms. Now, this term compound atom means nothing but molecule. So within brackets, write down molecule. So in present day context, I can say he wanted to say that atoms of different elements combine in a fixed ratio to form molecules. So term compound atom stands for molecule. And the point is still correct. Write down still correct. So this was Dalton's model of an atom. Now, moving on to the next topic, Adam, laws of.
सर आप एक बार आइसोटोप वाला पॉइंट रिपीट कर सकते हो, मेरा वो स्किप हो गया.
That point was, he said that atoms of different, all atoms of an element are alike. It means there's no difference between any two atoms of the same element. But that was proved wrong with the discovery of isotopes, because isotopes are atoms of the same element, but they have different masses, right? That was the point. Okay. So next heading, write down laws of chemical combination. Now we'll study about many laws of chemical combination. First two laws will be easy, but after that, there'll be calculations involved. Although there'll be numericals in first two laws also. That number one, law of conservation of mass. Law of conservation of mass. You know the statement, very easy. It states that matter can neither be created nor destroyed, neither be created nor destroyed during a chemical reaction. During a chemical reaction. For example, pattern number 1, I'll give you 2 examples. Number 1, when 4 grams of hydrogen, when 4 grams of hydrogen and 32 grams of oxygen are allowed to react together, 36 grams of water is produced. We start with 4 plus 32, 36, and after the reaction we get 36 grams of product. It means matter is neither created nor destroyed. This is according to law of conservation. Next paragraph. Sometimes, now this will probably disturb you a bit, sometimes total mass of reactants is equal to the total mass of products, as in the above example, the example which I gave you, 4 plus 32, as in the above example, but it is not always so. It is not always so, even though law of conservation is still valid. Law of conservation is
So
still.
could you repeat?
I'll repeat. Language may slightly change, right? Although total mass of reactants is equal to total mass of products, as in above example, but sometimes it may not be so. It may not be so, even though law of conservation of mass is still valid. Now, this is something interesting.
So how is that possible?
I'll giving an example. I said we start with certain mass of reactants, let us say X grams, but total mass of the product obtained is not X grams. But I said law of conservation is still valid. Now, in this case, language used is very important. For example, when 20 grams of hydrogen, when 20 grams of hydrogen and 80 grams of oxygen are allowed to react together, 100 grams of water is not produced, rather 90 grams of water is produced and 10 grams of hydrogen is left unreacted. 10 grams of hydrogen is left unreacted. I'll explain, just don't worry. It's something like this. Let us say you have 500 rupees in your pocket. You go to the market, buy some fruits. Let us say you spend 200 rupees on fruits. Total amount you initially had, 500, is not equal to the total worth for which you have bought fruits. Is not equal to fruits of 500 rupees. Rather, 200 rupees of fruit and 300 rupees you still have in your pocket. So 500 initial value is equal to 500 after the process of buying fruits. How come? How is that 500 after buying fruits? because you have 300 in the pocket, plus you have 200 rupees worth fruits with you. So that is law of conservation. Now I'm coming to the example which I gave you. Write down in the form of equation. 2H2 plus O2 gives 2 water. Earlier I gave you the example that 4 grams and 32 grams combine to give 36 grams of water. Now, if I say I have 4 grams more will combine with 36, will 32 will give 36. 4 more, right? If I keep on doing this, this will be 20 grams of hydrogen. But for 20 grams of hydrogen, how much oxygen do I need? 5 into 32, 160. But I don't have 160 grams of oxygen. It means 32 combines with this, correct. I'll get 36 water. 32 combines with this, correct. I'll get 36 water. But 16 will combine with 2 grams. 16 will combine with 2 grams to give 18 grams of water. So this is 4 plus 4 plus 2. 10 grams of hydrogen has combined, has reacted. 10 grams of hydrogen is still left. Oxygen, 32 plus 16. Total 90 grams of 80 grams of oxygen we started with, and entire 80 grams of oxygen has exhausted. Will give 36 plus 18 will give 90 grams of water. So after the reaction, I have 90 grams of water. I have 0 gram of oxygen. I have 20 minus 10, 10 grams of hydrogen is still left. So I should not say that total mass of reactants is equal to total mass of products. Never say that. May or may not be. Rather, we should say that total mass of reactants we start with is equal to the total mass of products formed plus reactants left. We'll study this topic in a refined manner later in this very topic, in this very chapter, and that will be the topic called limiting reagent. And solving numericals on limiting reagent initially is difficult for children, but it's a very interesting topic. Will come maybe after a couple of classes. So write down. Next paragraph. Thus, I'm slightly modifying the statement. Thus, precisely, this law means that total initial mass of reactants is equal to the total mass of.
सर आप एक बार स्टार्टिंग से बोल दोगे प्लीज.
Please listen carefully. Repeat करने में problem होता है बेटा, because at the same time I'm recording the class. That is the problem. Okay. Thus, precisely, this law means that total initial mass of reactants is equal to the total mass of products formed and reactants left. Right? I've shared one numerical on WhatsApp, and by mistake it has been printed 2 times because I copied and pasted. It has gone 2 times. We'll solve this numerical. I'm sharing this numerical in the chat box of this video as well. Yeah. You'll find this in the chat box as numerical number Intext Numerical-12. So the numerical is 8 grams of sodium hydroxide reacts with 9.8 grams of sulfuric acid to give 3.6 grams of water and so many molecules of sodium sulfate. Prove that the data justifies the law of conservation. So NaOH plus sulfuric acid gives sodium sulfate plus water. I have not balanced the equation, and there's no need to balance the equation, right? There's no need. Now we started with 8 grams of NaOH, 9.8 grams of sulfuric acid. It means total we started with 17.8 grams of reactants. After the reaction, total mass should remain the same. We get 3.6 grams of water and so many molecules of sodium sulfate, 6.022 into 10 power 22. Now, what we'll do is we'll calculate the weight of so many molecules of sodium sulfate. That weight plus this weight, 3.6, should be equal to 17.8 grams. If it is so, then law of conservation of mass is valid, it is satisfied. Now, how do we calculate weight of so many molecules? We'll use mole concept. See, Avogadro number of molecules will be 1 mole, and 1 mole of sodium sulfate will weigh equal to molecular weight, that is 142 grams. So 6.022 into 10 power 22 will weigh how much? If you calculate 22 into 10 power 23 into 6.022 into 10 power 22. When you calculate, this will come out to 14.2 grams, right? Weight of so many molecules is 14.2 grams. Now, at the end, you will write 14.2 plus 3.6 is equal to initial mass we started with. Therefore, it proves law of conservation. Although this type of numericals are not popular, but this type of numericals can be there. So that was the first law of chemical combination. Right on. Second law. Law of constant composition. Second law is law of constant composition oblique law of definite proportions. Law of definite proportions. You know it very well. If we talk about, let us say, water. Water means I'm talking about pure water, right? If we remove all impurities, whatever pure water we get, I'm talking about that. If we take water from any source, we take water from tap, although it contains a lot of impurities, I said we remove impurities, then purify it. Take water from tap, take water from any city of any country, take water from lake, pond, or gutter. Them totally in a bad shape, but purify it, I'm saying, right? Remove or take out pure water. It will always contain hydrogen and oxygen. It will always contain these two elements in 1:8 ratio by mass. That's what is the law, right? That's what is the law. Now write down the statement. It states that a compound is always made up of same elements chemically combined together in the same ratio by mass, irrespective of its source. Write down another statement for this law. Write down or. Second statement is percentage composition of a compound remains constant irrespective of its source. For example, water obtained from different sources always contains H and O, hydrogen and oxygen, combined together in 1:8 ratio by mass. So either we can say 1:8 ratio by mass, or we can say contains 11.11% hydrogen and 88.89% oxygen. So you can say in terms of percentage or in terms of ratio by mass. I'm sharing one numerical. This will be numerical number Intext Numerical-13 in your description box or chat box. I've shared on the WhatsApp and in the chat box also. So numerical is 2.4 grams of magnesium combines with, I'll tell you the way you should solve without facing any problem. 2.4 grams of magnesium combines with 1.6 gram of oxygen to form magnesium oxide. 16 grams of another sample of magnesium oxide gave 9.6 grams of magnesium on reduction. Prove that the data illustrates or justifies the law of constant composition. See, magnesium oxide, sample 1, sample 2. 2.4 grams of magnesium combines with 1.6 gram of oxygen. When I say combines with, it means weight of magnesium oxide will be this plus this. It means 4 grams. 16 grams of another sample of magnesium oxide. Now, second sample is 16 grams of magnesium oxide. Gave 9.6 grams of magnesium on reduction. What is reduction? Removal of oxygen from magnesium oxide is reduction. It will leave behind magnesium. So gives 9.6 grams of magnesium. It means how much was oxygen present? This minus 9.6, it will be 6.4. Now I'll calculate the ratio of magnesium to oxygen. Ratio is nothing but magnesium divided by oxygen, right? Or you can calculate percentage. Sometimes calculating percentage takes time. So this will be 2.4 is to 1.6. This ratio is nothing but 3:2. This will be 9.6 is to 6.4. This is also 3:2. At the end, you'll write, since ratio by mass remains the same, it proves the law. It proves the law. Now, the more important thing is that sometimes this law fails. In which type of cases this law fails? With the example I'm telling you. Write down. However, this law is not applicable if different molecules of the same compound contain different isotopes of an element. For example, consider water containing protium and deuterium. Protium and deuterium, you know, are isotopes of hydrogen containing protium and deuterium. Now, you have to copy from the board. H is protium, D is deuterium. This is isotope of hydrogen. Protium atomic mass is 1, deuterium atomic mass is 2. I hope you know that. Now, I cannot write H, I'm write hydrogen. Hydrogen means protium as well as deuterium. Hydrogen is 2, oxygen is 16. In this case, hydrogen, which is in the form of deuterium, will be 2 into 2, that is 4. And oxygen will be same, that is 16. It means percentage of hydrogen will be 2 divided by total, or you can take ratio. Hydrogen is to oxygen. This will be 2 is to 16, 1 is to 8. In this case, it will be one is to 4. So if different isotopes of the same element are present in different molecules of the same compound, then of course this law is not valid. Next, third law. This is a very, very important law. Let us see how much we are able to complete today. Write the heading, law of multiple proportions. Law of multiple proportions. And I'll do one thing because only 5 minutes are left. I'll just explain this law and then dictate you next time. So you're not writing anything. You just look at the board. What does this law mean? It's slightly typical. In this law, we'll consider 2 elements. Yes, please. We'll consider 2 elements, and these 2 elements will combine together and form minimum 2 compounds, 2 or more than 2 compounds, right? Let us say we consider hydrogen and oxygen. You know, hydrogen and oxygen combine to form, there should not be any other element, only 2. These 2 elements, hydrogen and oxygen, they combine and form 2 compounds, which are water and hydrogen peroxide. Hydrogen is 2 grams, oxygen is 16. In the second case, hydrogen is again 2 grams, oxygen, sorry, H2O2. Hydrogen is 2 grams, oxygen is 32. Mass of hydrogen is same in both, but the mass of oxygen is different. If we take the ratio of these different masses of oxygen, which combine with the same mass of hydrogen, this ratio is a simple whole number ratio. Now, let me define it. You need not write. Definition will be a bit difficult. So law of multiple proportion says that the ratio, you look at my finger where I'm pointing, ratio between different masses of one element which combine with the same mass of the other element is a simple whole number ratio. Is a simple whole number ratio. In this case, there was almost no calculation involved. but they may be numericals in which calculation will be required. I'll take another example. Iron and oxygen. Iron and oxygen combine to form, one is FeO, ferrous oxide, and Fe2O3, ferric oxide. Don't write anything. I'll dictate the same examples next time. Don't worry. Iron, oxygen. Atomic weight of iron is 56. So 56 combines with 16 oxygen. This is 2 iron, means 112 combines with 16 into 3, 48. I'll fix the mass of one of the two elements. Like it is 56, I'll try to make it 56. Or I make it 1 gram, 1 gram. I make it 16, this I take 16. So you convert mass of one of the two elements, same in both calculations, and then take the ratio of the other element. Like I'll take very simple calculation. Iron, oxygen, no change in this case. Now think in a unitary method way. Unitary method, what we do is 56 grams of iron combines with 16 grams. Now, in case this is also 56, then it will combine with how much? So 56 combines with 16. Sorry, 112 combines with 48. 56 combines with how much? Last time I'm repeating. 112 combines with 48. 56 will combine with 48 divided by 112 into 56. That will come out to 24. Different masses of oxygen which combine with the same mass of iron, they have a simple whole number ratio, and this is 2:3. Right? So again, I'll define it. Ratio between different masses of one element which combine with the same mass of the other element is a simple whole number ratio. Right? Chale. Class on Saturday, please don't forget. Saturday class is at 9. Forgotten the time. What's the time? 8 to 9. Saturday is 8 to 9. And please join in on time, because I have to admit you in the Zoom meeting. So in case I'm looking at the board, I'll not be able to look at my computer whether it's waiting or